Greetings. Thank you for understanding my situation, even though you don't really have a choice. Sorry, we have to do the notes recording again. So let's go into lesson 9.1 today, where we are working with geometric sequences. In a geometric sequence, let's underline this, each term is multiplied by the same number to get the next term. Let's finish underlining. This number, this multiplier, we are going to call it the common ratio, and we're going to call that R, okay? So when we have a multiplier, a common ratio, when we multiply a term in the sequence by it, it gets us the next term. We can say we have a geometric sequence. So in this example here, our sequence is 3, 12, 48, 192. If you take 3, multiply by 4, you get 12. 12 you multiply by 4, you get 48. 48 you multiply by 4, you do get 192. So this is a geometric sequence with an R value of 4. So determine if the sequence 2, 6, 18, 54 is a geometric sequence. So what you do is you divide a term by the previous term, because then division is the undoing of the multiplying. So we're trying to find the multiplier. So we start with a term and divide it by its previous term. So that's what they've done here. They started with 54. They divided that by the previous term, 18. They got 3. Then they took the 18, divided it by the previous term, 6, and got 3. Then they took the term 6, divided it by the previous term, 2, and got 3. So we would say this is a geometric sequence. R equals 3. The multiplier is 3. Now our other one over here, it says determine if the sequence 5, 10, 15, 20 is a geometric sequence. Divide each term by the term before it. So again, they started at the end, divided it 20 by 15, got 4/3. 15 got divided by the previous term, 10, got 3/2. It's already broken down. It is not geometric. And as they do the last one here, 10 divided by 5, now they get 2. So this is not a geometric sequence. But we have studied some sequences that this actually is. Remember, we have the arithmetic sequence, where if you can add or subtract the same amount, a common difference, and in this one, if we just keep adding 5, the sequence continues. So this is actually an arithmetic sequence. Okay, let's go down here and do some practice together. So determine if each sequence is a geometric sequence. Show support. So let's start with our last term, 4. We would divide that by the previous term, 8. And we're going to, let's just simplify that as a fraction and say we get 1/2. Then we'll take the 8 and we'll divide it by the 16. Again, we can simplify that to 1/2. Take the 16 now and divide it by the previous term, 32. And again, we can simplify that to 1/2. So we are going to say is a geometric sequence with R equals 1/2. So that's determining with support. Okay, number 2. Start at the end with our 32. We'll divide it by negative 16, the previous term. Positive divided by a negative is a negative. There are 2 16s in 32. Negative 16 divided by 8. Negative divided by positive again is a negative. There are 2 8s in 16. But you have to make sure it works all the way through, because sometimes it can fool you. So we just got to carry on here. 8 divided by the previous term, negative 4. Positive divided by a negative. There are 2 4s in 8. So again, we got a constant ratio, we call it. So we say is a geometric sequence And once we decide it's a geometric sequence, remember we say what is the multiplier, what is that constant ratio, that R value? It is -2. In other words, if you keep multiplying by -2, you get the next term. -4 at the beginning times -2 is 8. 8 times -2 is -16. Okay, let's look at our next one here. 2, 4, 6, 8. Well, let's start. 8 over 6. Well, that simplifies to the fraction 4/3. 6 over 4. Well, that doesn't simplify to 4/3. That simplifies to 3/2. And if we just finish up here, 4 divided by the previous term, 2, we get 2. We definitely do not have a constant ratio, is not a geometric sequence. And we have the work right there to support it. We could not find an R value. But I'm hoping you do recognize what kind of a sequence it is. From 2 to 4, 4 to 6, 6 to 8, it's going up by 2 every time, so it is an arithmetic sequence. Okay, we have one more that we're going to do here. We have, at the end here, we have 0 and 4/10. We're going to divide that by the previous term, 2. So 40 cents is what we have on the top. If we divide that in half, what do we actually have? We have 20 cents, or 0.2. If we take the 2 now and divide it by the 10, 2/10, its decimal name is 0.2. If we take the 10 and we divide it by the 50, well, if we take 10 and divide it by 50, we should get 0 and 2/10 again. So we are going to say is a geometric sequence. We found a constant ratio called R, and that R value is our multiplier, 0 and 2/10. Okay, this is determining if a sequence is a geometric sequence or not, with work to support it. So this is what I would expect in the homework for tomorrow also. Okay, let's move on to the back side of this page. Find the next 3 terms in the geometric sequence, 1, 4, 16, 64. Well, in reality, if they say in the geometric sequence, they're already telling us it's geometric, so we really would only have to do one of these. We just have to find the R value. So you can get by with, in the problems like this where it says find the next 3 terms in the geometric sequence, you just need to find the R value by doing one division problem. And then you would show the work starting at the last term, which is 64. You would show multiplying it by 4 to get the first of the next 3 terms. Take that 256 times the multiplier 4 to get the second term of the next 3, and the 1024 times 4 to get the third term of the next 3. Okay, so let's look at our directions here. Find the common ratio in each geometric sequence. In other words, they're telling us it's a geometric sequence, so to find it, we can use either 125 divided by 25, or 25 divided by 5, or we could really take the easy way out and do 5 divided by 1. Our R value is 5. The constant ratio is 5. So now we will use that as our multiplier. We will start with our last term given, multiply it by 5, get 625. We will take 625 and we will multiply that by 5. 3,125 is what you should get. They wanted 3, so we got to go one more time. 3,125 times 5. And this time we're going to get 15,625. The next 3 terms of our sequence are those 3. And the sequence is getting larger as it goes along, so this makes sense. Okay, in number 6, we actually have we have alternating signs. We have a negative, positive, negative, positive. So the next one better be negative, then the following one positive, and the next one negative again. Well, we just need to find the R value first. So let's just take 12 and divide by negative 6, because we can do that easily enough. Positive divided by a negative, 12 divided by 6, 2. Our R value is negative 2. And now we will use that as our multiplier. 48 is the last term given to us. So we multiply that. We did predict that the next term should be negative. Now the next term should be positive. Let's see if that's going to happen. A negative times a negative is a positive. And 96 twice is 192. And of course our next term should end up negative. And we have a positive times a negative. And we are going to end up with a negative. There's our next 3 terms. Whoops, kind of cut off the negative sign there. Let's get it back. Okay. Okay, so our next 3 terms of that sequence. Geometric sequence. Let's do another one. Let's do 6 divided by 4. We always kind of pick out the easy ones. 6 divided by 4. We have 2 ways to treat this. We can treat this as a fraction, or if this fraction is a nice decimal, maybe you want to use the decimal name for it. And it's probably a good idea to use the decimal name because when one of the terms is already in decimal form, it's a good idea to keep it going in that manner. So this actually does divide out to 1 5/10. So our R value is 1 5/10, 1.5. And now we are going to do our multiplying. 13 5/10 times 1 5/10. And write down all of the digits that happen in these. There's nothing that says to round, so this is going to be 20 25/100. Now we'll take that term times our multiplier, our R value. What do you get? Go ahead and multiply it out. And after you have that, now you're going to take that one times your multiplier, your R value of 1.5, 1 5/10. And what do you get for that one? Again, remember I said write all the digits that you see on that calculator. And our sequence was growing and it's continuing to grow, so that's good news. Okay, and our last one. Well, you know what? Maybe this time we don't want to take the first 2 terms, 1/2 divided by 1/4. Maybe we could just move further down the sequence and say, oh, I like that 2 divided by the 1. That's 2. R equals 2. I like that one. Of course, if we took 1/2 and divided it by 1/4, that's asking how many 1/4 are in 1/2, and there are 2 of them. So now we'll take our 2, multiply by 2. And we'll take our 4 and multiply by 2. And we'll take our 8 and multiply by 2. That almost seemed too easy. Okay, so when we know we have a geometric sequence, we're finding the next 3 terms, this is the work I would expect to see. One division problem, helping you get the multiplier, the R value, and then showing using that multiplier. You can use your calculator, but not without me showing what went into your calculator. Thank you very much. Okay, and last but not least, let's go to our last side here in our notes. I call it notes 2, but we're going to do it today. There are 2 ways to find a given term of a geometric sequence. So this is our second learning goal up there. I can find the nth term of a geometric sequence. So here they're saying find the 8th term. Right here they're talking about finding the 8th term of that geometric sequence. Well, again, the first thing you would want to do is you would want to, if you're going to use method 1, which is just keep doing what we were just doing on that last page, just keep extending the sequence till you get to the term number you want. Don't really need to do this, this many times, maybe just once is enough. Find your R value. The R value in this one is 2, and then continue to multiply, and they ended up with 640. When they were all done, they just don't show all the multiplying. Well, what if, though? 8th term, that's not so bad, but what if it's the 80th term? Do you want to have to multiply that many times? Well, back when we did arithmetic sequences, we had a way to find the nth term of an arithmetic sequence by using a formula. So I would suggest you just learn how to use this formula right away. So they're showing how the formula here, they're saying, look at what happened, this is what's going to help you decide how could the formula, where did it really derive from. I want you to circle the formula right here in the middle. A sub n, that should look familiar. Remember, that means what term are we looking for? Equals a sub 1. A sub 1, remember, represents the first term of the sequence. Our R value, we now know that's our constant ratio, our multiplier, raised to the n minus 1 power, where remember, let's underline this, n is the number of terms. Okay, and we already know that R is the common ratio. So when they use the formula, they got the same answer, okay? Let's just go do some practice together, and you can use that as another example to study, okay? So number 1, they're telling us a sub 1 is 7. So they're really telling us right now the first term of the sequence is 7. The R value is negative 2, or in other words, the multiplier is negative 2. So right now I could already say, if I take 7 times negative 2, I know the second term of my geometric sequence. And I could get the third, and I could get the fourth. Using method 1, I could just keep multiplying till I have 10 of them. Using the formula, I am looking for the a sub n, I'm looking for the a sub 10 value. Remember, the a sub 1 is that starts us out. We multiply the first term by the R value, which in this case is negative 2, raised to the n minus 1 power, so 10 minus 1. Why minus 1? Because one of our terms is already represented in that first term. That 7 is already taken care of. So we just really need to multiply 9 times to get the 10th term. Well, we have to make sure that we follow order of operations. We do not take 7 times negative 2. We take negative 2 to the 9th power first. So we're going to find out what that is. And then after we have that, which is negative 512, that's negative 2 to the 9th power. Now we will multiply that times our first term of 7, and we will say that the 10th term of this sequence is negative 3,584. Okay, I'm feeling pretty good about that because the second term was a negative. That's an even number. 10 is an even number. And we have a negative term again. So I'm feeling pretty good about that. Okay, number 2. They're telling us again what the first term is. They're saying the first term is negative 4, so we'll put it right here. They're telling us what the R value is, so we'll put it right here. We're looking for the 8th term. That's our n value, so 8 goes here, n minus 1. So a sub 8, negative 4 is going to stay negative 4. 3 is going to be raised to the 7th power. So a sub 8 is equal to negative 4, not times 3, but 3 to the 7th power. What is that? After we have that, then we'll go back and multiply that times our first term and get our 8th term of this sequence. So personally, I think it's better to use the formula because then I don't have to show all that multiplying and keeping track of making sure I have enough multiplications. Okay, in this next one, it says the first term of a geometric sequence is 2. Let's identify that. That's our a sub 1. And the common ratio is 3. That means r equals 3. And they want the 7th term. So n is going to be 7. So we're going to say a sub 7. We're looking for the 7th term. We will get it by starting with the first term. Multiply that by the ratio, the r value, the constant ratio, the r value of 3 raised to the 7 minus 1 power. So now we will have a sub 7 equals 2 times 3 raised to the 6th power. What is 3 to the 6th power? 729. And now we'll take that times the first term of 2, so we will double it, and we will get 1,458. So we had a sequence that started at 2. It was being multiplied by a positive number. It should be growing because it is being multiplied by a number greater than 1. So it seems reasonable what we got. Okay, and our very last one. Oh, I kind of like to always check this out. 12th term, the second term, the 4th term, the even number terms are negative. So when I'm done, I better get a negative number. The 12th term better be negative. So we know that our a sub 1 is 5. It's the first term. We know that we don't know our r value, so we're going to have to get it. Let's take the negative 15 and divide it by the 5. And that gives us negative 3. And then our n value is, they want the 12th term. So here we go. A sub 12 equals 5 times our r value of negative 3 raised to the 12 minus 1 power. Our 12th term is going to be found by taking 5 times negative 3 to the 11th power. Thinking negative 3 to the 11th power is kind of a larger number, even though it's going to turn out negative. Its absolute value we can say is large. Negative 177,147. I hope that's what your calculators say. And now we will take that times a positive 5, and we will end up with a negative 885,735. And remember our prediction in the beginning? Should be a negative number, and it is. Feeling good about that. Okay, these are the 3 types of things you're going to be doing in your homework today. You'll be determining if the sequence is geometric, and then you will be given geometric sequences and told to find more terms. And last but not least, you will be asked to find the nth term of a geometric sequence. Then you're also going to do some problem solving, meaning you're going to use this knowledge now and apply it. So good luck, and hopefully I will see you tomorrow.